طيب يا شباب اليوم بإذن الله in class we'll do a tutorial for the memory part of unit 2, and also if you have any questions regarding memory or anything before, we can ask after we after we finish the tutorial. طيب, so for question 1, it says the following memories are specifies so the following memories are specified by the number of words times the number of bits per word, like we usually write the memory. We have two numbers, one will donate the words in your memory and one will donate the number of bits in your memory. So a quick refresh for a small memory. If I have an 8-word memory, so this goes from 0 to 7, and I have 2 bits per word. The way I write this memory is 8 by 2. That means I have 8 words and each word holds 2 bits. So the question is, how many address lines and input-output data lines are needed in each case? طيب, these are the memories we have. It's easier to start with the number of input and output data lines because your DIN and DOUT has to be the same size, and they all have to do with the number of bits in your word. بالتالي all you need to plug in this row is the same number of bits per word that you have in here. That's going to be the size of your DIN and DOUT line. So this will be 16, that's 32-bit, 16-bit, 64-bit, and 1-bit. طيب, for the number of address lines, means how many bits your address should have so you can address these memories. For the first one is 2K. So mathematically the way you do it is log 2 of 2K. And of course you need to memorize the special powers of 2. So you can do this quickly. We have 2 to the 10, 2 to the 20, 2 to the 30, maybe 2 to the 4. We're not going to use 2 to the 40. So 2 to the 10 is K, which is kilo. 2 to the 20 is mega. And 2 to the 30 is giga. So this will equal to log 2 of 2 to the power 1 multiplied by 2 to the power 10. So if you take log 2 of this number, that's going to be 11, which is the addition of the exponents. You know that log 2 of, for example, 2 to the 6 is equal to 6 multiplied by log 2 of 2, and this is equal to 1. So what you're really doing is just taking the exponent and plug it in. If I need 11 bits to address a 2K memory, regardless of how many bits per memory it is, فإذا كان 2K by 8 أو 2K by 16, at the end you need 11 address bits. تمام؟ لازم تفرقوا بين how many words in your memory and how many bits per word. طيب, let's do 512K. That's log 2 of 2 to the 9, which is 512, multiplied by 2 to the 10. So we need 19 address lines. 2 mega, log 2 of 2 multiplied by 2 to the 20. So that's 2 to the 1. This is equal to 21. Okay. 64 meg. That's log 2 of 2 to the 6 multiplied by mega is 2 to the 20, so that's 2 to the 20, which is equal to 26. Adding the exponents, you get the answer. 2 gigabytes, that's log 2, 2 to the 1 multiplied by 2 to the 30 in this case. So that's 31 bits of address. Okay. في سؤال؟ طيب. طيب, question 2. We have a 256K by 16 memory RAM that uses coincident decoding. قلنا coincident decoding انه instead of having a memory that looks like this, we will transfer the structure and make a different organization to make the memory يعني as square as possible. بهذا الشكل. It's gonna be the same size in terms of words. It's gonna be the same size in terms of bits per word. ولكن the organization is different. So the way we do it is instead of using one large decoder, we'll split into 2 decoders and we'll split the address lines. The most significant bits will go into the row decoder and the least significant bits will go into the column decoder. طيب, so we said this chip uses coincident decoding by splitting the internal decoder into row select and column select. So the first question is assuming that the RAM cell array is square. Square يعني I'm turning the structure into يعني as much as I can to a square. What is the size of each decoder? I mean, what's the size of a column decoder, of the row decoder, and what's the size of the column decoder? طبعا in the exam, the question will stop here. This part is for you to decide or for you to work on. The way to do it, let's see how many words in the original memory اللي هي 256K words. So let's see how many bits you need to address them. So 2 to 56K is 2 to the 18. 2 to the 18 is 2 to 56K اللي هي 2 to the 8 multiplied by 2 to the 10. That's 2 to the 18. And then we have 16 bit per word, so that's 2 to the 4, which is 16. So the total you have 2 to the 22. Okay, you have 2 to the 22 bits in your whole system. So if you want to split 2 to the 22, you will have half of the address bits go to the row decoder and half go to the column decoder. For our row decoder size is going to be 22 over 2, which is 11 bits. So out of 22 addressable bits, I will take 11 for the row decoder. طيب, تعال الكولوم ديكودر كم باقي من ال 11؟ باقي المفروض 11 bit for the column decoder. ولكن if you split it this way, if you make your decoder, your column decoder is 11 bit, معناه انت you can address each bit individually in your memory. ولكن this memory have 16 bit per word. فبالتالي حأطرح number of bits from log 2 of 16, so I can only address 16 bit at a time. فبالتالي the column size decoder is going to be the remaining 11 bits minus the number of bits I need to address البيتس per word. I'll take it out. فبالتالي that's 11 minus 7 11 minus 4 11 minus 4 this will equal to 7. فبالتالي the size of the decoder for the row select I have 11 bits, that means that's 11 to 11 to 2 to the 11, which is 2048. So the row decoder is 11 to 2048 decoder. And for the column decoder, that's going to be 7 to the 7 to 128 decoder. تمام. ف this decoder is smaller because for each address ايش هذا؟ شايفين الملف يا شباب ولا اختفى؟
لا
طلع؟
لا
طالع
الحين جاي.
جا. طيب sorry. So again we split memory to 11 bits for the row and 7 bits for the column. So the size of the decoder, that's 11 to 2 to the 11, and this one is going to be 7 to 2 to the 7. So each output of this decoder, هذا الديكودر اللي عندك ياخذ 7 bits from D0 to D6. طبعا هنا عندك اللي هي 128 outputs. So each line من هذه اللي حتكون مثلا نفترض انه هذه active, this will connect to 16 blocks of memory at a time. So each one will output 1 bit, and then the total is going to be 16 bit. That's why we had to take out the number of bits per word, so we can يعني that means we're making the same memory but with a different structure. احنا فقط غيرنا the organization of the memory and how this memory is going to be organized internally. ولكن the way it works, it's going to be exactly the same. The data bit is 16. Your result has to provide 16 bit of data, and the number of words also has to be the same. طيب, determine the row and column selection lines that are enabled when the input address is 195.072. That's in decimal. So first thing to do is to convert this number into binary. Converting this number into binary will result in this number. So the lowest 7 bits will go into the column select, and the higher 11 bits will go into a row select. So for the column number, that's going to be column number 0. We're converting back to decimal. And this one, if you convert it back to decimal, it's going to be so that's 4, 1, 2, 4, 8 plus 16, 32, 64, 128 and 256. So that's 16, 32, 64, 128, 256, and then 124.
طب
تفضل.
بالحاسبة طلعت 1524.
1524. Okay, yeah, sounds correct. تمام. ف this is That's gonna be row number 15,024, and it's gonna select column number 0. Okay, so this is for coincident decoding. Remember that coincident decoding is splitting row and columns. يعني مو لازم اكتب الجزء هذا من السؤال. I can just write the size of the memory and I say that it's using coincident decoding. You should automatically understand that this memory will have a row select and a column select. طيب. If there is any question يعني ask before we move into next question. طيب, using the 64K by 8 RAM chip shown below, you are provided with this chip, which is 64K by 8. That I can also write 64 kilobyte. Byte means 8-bit. So using the 64K by 8 shown below, plus a decoder, you have the decoder here, with active high outputs. Active high outputs معناته one output will be 1 and the rest will be 0. Construct the block diagram for a 512 by 16 RAM. That means if you are comparing the number of words in the memory you have and the number of words in the memory you are building, they are different. So first, that means we're building a larger decoder. And if you compare the data bit of the memory you have and the data bit of the memory you're building, that means we're also constructing a wider decoder. Just like the last slide in memories that we went through last time. طيب, فهذه الميموري اللي عندنا, it has, if you have 64K, that means you have log2 of 64K, which is 2 to the 8, 2 to the 6 by 2 to the 10, which is 16 bits of address. That's why you have the address is 16-bit. The input data and the output data is 8 because you have that number of bits per word. And then you have the two control signal, which is chip select and read write bar. So the memory we are building is going to be as follows. The final block diagram of the memory we want to build is going to be a 512K by 16. So you will have data in 16-bit, data out 16-bit. بالنسبة للأدرس, log2 of 512K, that's going to be 19. That's 2 to the 9 multiplied by 2 to the 10. And then we'll have 1 bit for chip select and 1 bit for read write bar. هذا the end result. So how to construct this from the inside using these chips? By drawing the connections to the following provided diagram. طيب, first we need to figure out how we're gonna route the address. احنا جاينا 19-bit address, and inside these chips have 16-bit address. So you will take the 16-bit address line أو from اللي هو الأدرس from 0 to 15, that's 16 bits. You'll take that and you'll route it to all the address lines in your memory. طبعا how many of these do we need? أول شيء تحتاج 2 of them. طبعا address is going everywhere. بالنسبة لل 16-bit address, that's going everywhere. تمام. How many you need? انت you're building 512 from 64K. That means you need come 8. 64K is, yeah, you need 8 by 64 is equal to 512. So you need 8 chips. استنى لا، تحتاج مو 8، تحتاج 16. ليش؟ you need 8 in each row. So this will give you 512 by 8, and this will give you 512 by 8. If we have خلينا أقول هنا total number is 8. You'll have 8 chips here and 8 chips here. This will be 512 by 8, and this will be 512 by 8. Why do we need 2? Because our data bit is 16. So this one will give me data out from 0 to 7, and this will give me data out from 8 to 15. تمام. طيب بالنسبة للريد رايت بار, all your chips will be connected to the same read write bar that's coming from the outside. كلها حتكون ايش؟ read write bar, all of them. طيب كم باقي عندي memory؟ أنا استخدمت 16 bits for addressing these chips. باقي عندي 3 bits اللي هي 16 to 18. So bit 16 to 18 will be here. So address of 18, address of 17, and address of 16. Considering that this is A2, A1, and A0. The enable of this decoder will come from the chip select of the big decoder that we drew before. طيب بعد كده عندي output of this decoder. الزيرو will enable the first line of memories. 1 will enable the second line of memories. You will connect them to both chips. لأنه هذه الاثنين they are just providing the 16 bit. لكن من ناحية الادرس it's gonna be enabled for both. and then for 2 يعني مشكلة ما أقدر أرسمها كاملة، ولكن anyways you understand the idea. Each one of this will go into one row of memory that you have. اليسار واليمين, this is to provide the 8-bit output. this one if it's going outside حنجمعها مع بعض، حتصير عندي data from 0 to 15 كاملة 16 bit. If this is not clear, we can do an example for a smaller memory if you want. ولكن إذا وصلت الفكرة we can move on. في أي سؤال على building larger and wider memories؟
داتا ان يا دكتور عادي سيجنال عاديه صح؟
داتا ان حتكون حتكون بس data in is the same as data out. So data in حتكون قلنا هذا الميموري اللي هو 512K by 16. الداتا in of 512 by 16 is 16 bit. تمام. وهذا عندي 8 bit. فبالتالي from dn اللي هنا اللي جاي من برا I will route just as we did with d out. حيكون هذا dn of 0 to 7 وهذه dn of 8 to 15. تمام. فكل اللي بنسويه انه هذا داتا ان اللي جاينا ال 16 bit داتا ان we're splitting half will go to this memory and the other half will go into this memory. طبعا from 0 to 7 of this هو مو تاخذ any 8 bit، لا you have to take the lower إذا استخدمت ال least significant here that's going to be 0 to 7 out، وإذا استخدمت ال most significant here that's going to be 8 to 15 out. Usually whatever you do in your data in you're going to do in your data out. لأنه في النهاية data in and data out has to be the same value. وفي بعض الميموريز اللي ما تسمح انك تسوي read and write at the same time actually have only one line for input output. هيكون عندك one line او one بس مثلا 16 bit، خلاص هذا هتستخدمه for read and write. If you put data at this bus and then you make read write bar equal to 0, that means you want to write, it will take the data from here and write to the memory. If you make r equal to 1, which is a read operation, the memory will output data to your bus, and then you can read it. But other type of memory at the same cycle you can read and write at the same time. If you put data طبعا هذا إذا باستخدام الادرس أو إذا عندك multiple address lines. Anyways هذه بس يعني معلومة جانبية إنه data in and data out has to be يعني the thing that you need to know إنه data in and data out has to be the same size. If that's 8-bit, that's going to be 8-bit. If that's 16-bit, that has to be 16 bits. طيب السؤال اللي بعده looks the same. Using 64K 8 RAM memory plus a decoder with active low outputs. Active low outputs معناته one of them is 0 and the other are ones. Construct a block diagram for a 256 by 16 RAM. طيب هذا اللي عندنا الآن block diagram مختلف. اوكي طيب block diagram of the memory you have is 64 by 8. First thing, that means we're building a larger memory because we have more words per memory, and a wider memory because we have more data bits per word. طيب let's see, we have chip select bar, this active low, وعندنا two signals instead of read write bar. We have read bar and write bar, so you are provided with a different chip. And okay طلعت موجودة. And we have one bus for the read and write IO data. طيب 256K from 64K to 256K you need to multiply by 4. معناته I need 4 chips so that I can have a 256 word, and I need another 4 next to them. This is to provide the 16-bit output. تمام. فالaddressing a number of words will activate either these two, or these two, or these two. فمعناته I need 4. The decoder has to have 4 outputs. You can also know that from the number of bits. عندي هذه 16 bits. 64K is 16 bits. 256K is 18 bits. So that leaves you with 2 bits for the decoder, and that means you have a 2 to 4 decoder. 2 to 4 decoder معناته you can activate 4 rows at a time. طيب one thing you need to consider يعني وانت تقرا السؤال, we said that this decoder is an active low. Active low decoder معناه all the output will be ones except the one that is active will be 0. فإذا مثلا كان عندي هذا A1 و A0 وحطينا 0 0 هنا, the output is 0 1 1 1. If this is 1 0 which is address 2, that means this is 0 and the others are ones. اوكي هذا البارت مفهوم, والمفترض يكون هنا في يعني bubbles at the output to indicate that this is an active low decoder. الشغلة الثانية اللي تنتبه لها إنه الميموري that you have, is it active low or active high? If the decoder is active low and the memory you have is active low, خلاص you can just connect as we did in the previous question. ولكن if this is active high, افترض إنه chip select is just CS, it's not active low. تمام. And if you want to enable this memory, you need to place 1, and if you want to disable it you place 0. فاذا استخدمت الديكودر هذا بدون اي تغيير او اضافه اي لوجيك معناته حتشغل 3 chips at a time and you will disable one chip, and actually you will be disabling the chip that you actually want. If this is active low and this is active low, خلاص we can just connect as we did before. So continuing on this question, address bit for the 256 goes from A17 to A0. So I'll take the highest bit اللي هي A17 A16. If this is A2 and A1, sorry, if this is A1 and A0. So this will enable, or this will provide input to the decoder. So the first decoder will take in chip select 0 across both memories. This one will go into chip select 2 and so on. تمام. هذا connection of the decoder. Now you were able to build 256 words out of 464K words. يبقى عندنا باقي الادرس، معليش، باقي الادرس اللي هو from A15 up to A0. You route these into all the address bits that you have or address lines that you have. هذه الادرس and so on for the remaining 4 lines. طيب we connected the address, we connected chip select. باقي عندي read write bar. دقيقة او اي اوكي read write bar. طيب ما حدد لنا هو الميموري هذا 256 باي 16 حيكون 1 بت او 2 بت، ولكن اذا ما حدد خلاص نعتبر انه it also takes read bar and write bar, so we don't have to add any logic, just route the read bar and write bar to the signal that's coming from the outside. طبعا this applies for all your chips. يبقى عندي الاي او داتا. الاي او داتا بكل بساطه we will route this one has 8 bit, فبالتالي this is D from 0 to 7 and this is D from 8 to 15. That's it. في النهاية in your output block diagram you will take these two, combine them to D0 to 15, and this is going to your output. طبعا all the data bit for this line will be connected to each other, and all the data bit of this line will be connected to each other. If you are lost, please ask. So overall, يعني if we want to do the whole solution as clearly as we can, هناخد قلنا A17 and A16 to the decoder A1 and A0. So let's call this X0, X1, X2 and X3. So chip select of the first line will take X0, and this is also will take X0. This will take X1, this will take X2, and this will take X3. تمام. All the address lines will be connected together. جميع الادرس line will connect to address from 15 to 0. All the read bar will take read bar, and all of the write bar will take write bar. So this is write bar, read bar, read bar, write bar. تمام and so on. This will take a also 15 to 0. فlet's call a 15 to 0 مثلا خلينا نسميها ادري z. So this is z z z z z and z. تمام. طبعا هذا نفس الشيء read right bar read bar right bar read bar right bar and read bar right bar. Data lines all will be connected together and this will provide اللي هي ما اقدر اسميها data out لانه this will be IO. So let's call it DIO. So this is DIO from 0 to 7 and this will be DIO 8 to 15. تمام كده we connected all the lines in the memory. طيب اي سؤال؟
دكتور
تفضل.
بخصوص الديكودر بس 2 to 4 هذا الحين اكتف لو صح؟
اي
إيه، بس خلاص.
active low لانه كتب في السؤال الديكودر is active low ولكن as a figure also this one should have bubbles at the output so you can know right from the output. ولكن مكتوب في السؤال plus a decoder with active low outputs. You have to check your decoder and you check the chip select of the memory you're using. If they are the same حل بنفس الطريقة اللي حليناها الآن. ولكن if it's different لا you need to invert يا اما you add inverters in front of chip select او you add inverters after الديكودر. الشغلة الثانية انه انا بفترض اذا الميموري اللي بنبنيه طبعا انا مو مكتوب في السؤال يعني انا بس كذا جات على بالي اذا الميموري اللي نبنيه نبغاه ريد رايت بار سيجنال واحدة فقط. تمام. لكن هذه chips have different يعني two signals. Can we split this one into these two? إذا read write bar خليني أفترض if I take I'm not sure if this is gonna work ولا لا ولكن أنا بفترض إنه البيج بلوك diagram اللي بنبنيه حيكون له only one signal read write bar and from the inside these chips have read bar and write bar. How can I split this signal into two signals and make it work؟ فافترض إنه I want to read من هنا. If I want to read معناته I'll place this as 1 صح؟ If this is 1 معناته this is 0 وهذه 1. Okay, so this is gonna work. If I put 0 here read bar will be 1 and write bar will be 0 so it will write. Okay, so the solution is a simple يعني a simple split. With bar you can make one input signal into two output signal. طيب جميلة هذه تنحط في الهوم ورك إن شاء الله. أوكي باقي لنا بعض الأسئلة يعني نظرية تقريبا. طيب answer the following questions. Part 1 how many 256 megabyte RAM chips are needed to provide a memory size of 1 gigabyte؟ يلا واحد يجاوبها. هذه الأسئلة ما أحلها. واحد يعطيني الحل. تبي تبني 1 gigabyte from 256 megabyte. How many chips you need؟
ما يفرق عدد البتس اللي بعد ولا؟
هنا ما تفرق لأنه يعني أقدر أكتب لك يعني نفسها هذه is 256 m by 8 او وهذه 1 جيج by 8 لانه خلاص كتبت لك بايت، فبايت معناته 8 بت.
اوكي.
ف they are the same width بالنسبة للداتا بيتس same width. هذه 8 bit per word وهذه 8 bit per word.
احتاج 8 يا دكتور.
8 8 ولا 4؟
4 ولا
4. ال 256 ميجا عبارة عن كم؟ 2 to the 8 by 2 to the 20، وهذه عبارة عن 2 to the 30 صحيح؟ ايوه الفرق بينها 2 bits، فبالتالي 2 bits يعني 4. So you need 4. You just need to divide this by that. You need 4. 256 يعطيك 500 او 512. 512 and 512 will give you another will give you 1 giga.
لو كانت 16 يا دكتور كانت بتصير 8 ولا؟
لو كانت مو 16، لو كانت 128. لو كان 128 ميجا تحتاج 8.
اقصد انها يعني مو بايت 16 بت.
تقصد هذه انها 16 بت؟ ايوه اذا كانت 1 جيجا باي 16 ايوه تحتاج 8، تضربها في 2.
اي هذا قصدي.
أيوة. فهنا you just need to divide the 1 gig by 250 so let's give you 4. طيب how many address lines are required to access the 1 gigabyte memory? How many address line you need? log 2 80.
لا 30 قاعد يقول 31.
30 ايوه اللي هي 2 to the 30 so that's 30. طيب how many of these lines are connected to the address inputs of all chips? الحين لا تنسى انه بنستخدم 4 256 to build the 1 gigabyte. ال 1 gigabyte يحتاج 30 address lines. فالسؤال هنا how many of these lines are connected to the address inputs of all other chips اللي هي الأربعة هذه تبعنا.
اثنين ولا
2 2 bits.
لا غلط
30 ولا؟
عكستها، لا مو 30، هي ال 30 جايتك هذه 256 ميجا. فجي you just need to check ال 256 ميجا كم تحتاج من address bit. this will be log 2 of 2 to the 28 which is equal to 28 bits. ال 2 bits الزيادة هي اللي حتروح للديكودر. الديكودر هذا 2 to 4 فالlast 2 bits will go here and then you can active each chip alone. لكن هذه will take in 28 bits. طيب specify the size of the needed decoder. We already answered it. إذا حتستخدم 28 for all the chips that leave you with 2-bit difference between the big memory and the memory you're using, وبالتالي the size is going to be 2 to 4 decoder. نشوف السؤال اللي بعده نفسه ولا نفس السؤال. Let's do it quickly. طيب how many 256K by 16 RAM are needed to provide a memory size of 2 mega by 16? data bit is the same, so I just need to divide 2 mega over 256K. This is 22 2 to the 1 لا 2 to the 1 و 2 to the 20 that's 21 minus هذه كم قلنا 80 20 ايش 21 2 ميجا 2 to the 20 هذه 18 صح 18 فيبقى عندي 3 bits فبالتالي the answer is 8 if you want to divide this by that the answer is going to be 8 لأنه it's going to be 2 to the 3. If you divide this by that, it's going to be 2 to the 3, which is equal to 8. So you need 8 chips to build 2 megabyte, 2 mega by 16 bit. You need 8 chips of 256 256K. يعني each for 256K will give you 1 mega, فبالتالي you need 8 for 2 mega. Just a simple division. طيب how many address line required to access the big memory اللي هو 2M by 16? That's gonna be log2 of the number of words, which is 2 mega. That's 2 to the 1 by 2 to the 20, so that's 2 to the 21. Sorry, that's 21 address lines, 21 bits. How many of these lines are connected to the address inputs of all chips? The small chip is 256, so that's 18-bit connected to the 256K memory. How did they get it? That's log2 of 2 to the 8 multiplied by 2 to the 10, which is equal to 18. Size of the decoder معناته I used, out of the 21, I used 18 for the small memory. That leaves me with 3 extra bits. So this is going to be a 3 to 8 decoder. If you want to check your answer, always the number of bit chips you need has to be the same number of output for the decoder. Otherwise, you have a mistake. لأنه each line of the decoder is going to enable one of your chips. هذا في حالة كان الداتا is the same. If the data is different هيكون مختلف القانون هذا ما راح يمشي. For building a larger memory, you have to check that the number of chips you have is equal to the number of output of the decoder. كان عندنا في السؤال اللي فوق كان عندنا 4 واستخدمنا 2 to the 4. طبعا إذا كان الداتا bit different, the answers here will be different, and you usually see some of these questions in the homework. طيب في أي سؤال يا شباب؟